I need to be sure that this model has been trained on data that I can trust, not on everything that you can find at Google.
Welcome to Trustworthy AI Chronicles, where we explore the cutting edge of AI security, ethics, and innovation. My name is Dr. Ihsan Alwani from the Center for Secure Information Technologies at Queen's University Belfast. Join me to uncover the risks, share the breakthroughs, and spotlight the people shaping the future of trustworthy AI. Today, we are honored to welcome Professor Stefano Di Carlo from Politecnico di Torino in Italy, a leading expert in hardware security and dependable computing systems. With extensive experience in AI resilience and system reliability, Stefano's research tackles some of the most pressing challenges in ensuring the trustworthiness of AI-enabled technologies. In this episode, we'll delve into his groundbreaking work on securing hardware platforms and discuss how his insights are shaping the future of robust and trustworthy AI.
Stefano, welcome to Belfast, and thank you very much for accepting my invitation today.
Thanks for having me here.
We'll start first by your journey, Stefano. I just highlighted that your role as professor in Politecnico di Torino, your focus is in the intersection between AI, systems reliability, security, emerging technologies, and so on. And your perspective on the matter of trustworthy AI is very exciting and interesting to me. Can you please start by sharing with us your academic journey?
Yeah, sure. So, my background is not from AI. I'm coming from hardware, and in particular, even if I'm a computer engineer, my PhD was on hardware testing, especially memory testing. So really far away from from AI, from whatever I'm doing today. So hardware is interesting for me. Architectures are interesting, and I think one of the main reasons why AI is becoming so powerful today is because at a certain point the hardware changed. It's not the algorithm. Yeah, we have better algorithms, we have better models, but we have better hardware. So my interest in AI is starting from the hardware perspective, how we can accelerate AI, how we can make it less power hungry. And since my background is in testing and reliability, how we can make everything reliable. Not maybe from the perspective of, when you talk about trustworthy AI, is more like, can we trust the models? My interest is more, can we trust the hardware that is running that models? So this is my journey into AI. And yeah, when you land in this field, then there are a lot of side problems. Reliability is one of the problems. Security is another one. I mentioned power consumption is another problem. So there are many dimensions that you have to consider. And yeah, if you want to trust AI, you need to consider all of them. It's not just about how good is your model, how good the results you get are from the model are.
That's very interesting, because I had a chat in a previous episode with Professor Yanjing Li, and we had also this discussion about trusting the hardware that is running the AI. And I think people lose sight of the fact that AI is not magic. And at the end of the day, it's going to be some code running on some architecture and some hardware. And while it is extremely important to think of what could go wrong from a model perspective, it is also with the same reasons to think that it is very important to think what could go wrong in the hardware that is running those models. How do you believe this has become such a critical area of research today, especially again, as we just said, people are more interested in the functioning hypes that, oh, this, can do that, ChatGPT, generative models generating very consistently human-like text and designs and images and probably soon videos as well. All of this is very exciting and interesting. Why do you think this is also important, and how of uh, uh, what is the importance from your perspective, the hardware
Yeah.
vision of it?
So I think there are some important key milestones in the in the AI journey. If you look back, AI first made its appearance in uh, let's say very high level computing models. So people were starting to use AI to solve general problems. But then at a certain point, we started to say, okay, we can bring AI also in the field. And well, some technologies, we all know autonomous driving is what we bring everywhere. But we are getting AI in our wearable devices that can detect if we have a stroke. So we are getting AI in applications that can impact our life. And well, when you come to that point, there's a switch, uh, because if you are using a ChatGPT to write your essay, and the essay is wrong, uh, you get a bad grade at the university, or you are writing a report and it is rejected, and well, you can survive. If your car crash because it doesn't recognize properly a pedestrian, and the crash is not because your model is not working. The crash is because there's a hardware problem in your car. Well, that's a completely different matter. And I think the introduction of AI into applications that are in the field and are potentially problematic for human safety bring a new problem. So now we know that the models are not 100% correct, but somehow we have the capability of computing the accuracy of our model. Now we know that together with that, the hardware can fail. And unfortunately, predicting how the hardware can fail is much more difficult. We have some background because in these applications we use electronics. So we have safety regulations, but still they were designed before AI and before the complexity of the hardware that you need to run AI was introduced. So those regulations, in my opinion, don't really make sense today with the AI hardware, and you need to rethink that.
Absolutely. That's actually very interesting. You're saying that this, so let's say safety standards and ISO, whatever standards that we have for safety in those previously just embedded systems or maybe control systems for those applications, what you are saying is that those are technically obsolete now
I think
because more and more is going to be AI embedded there.
I think so because of the complexity. And when there's something in these regulations that has been always like the key problem is that the regulation asks you to do as much test as you can. So usually companies that want to be certified, they have a certain amount of time, and they do experiments. They try to inject force, see what happens in that amount of time. Now, if your hardware is small, if your application is simple, you do the experiment, and maybe you can do 1 million experiments. Now, you have the same amount of time, the same amount of resources, but you need to run an application that is one order of magnitude more complex. That means the number of experiments you can do is lower, and the coverage you get is less precise. And this is a very big issue.
Yeah, I think this adds also to the fact that previous embedded algorithms are somehow deterministic. You can't verify them. If you have A, B, C, you can predict more or less what happens in the system. With AI, I guess it is not the case.
No. They are deterministic, and you make everything you can to have full determinism. Sometimes you want real time, you disable whatever performance enhancement method the hardware provides just to get determinism. Sometimes you disable cache, you disable branch prediction just to be deterministic. But you cannot afford it. If you want to run AI, you need to get all the computing power you need. Even if it's just inference, we are not training, but still inference can be very complex in those domains. And it's crazy. You on cars now, you have multiple GPUs. How can you call it embedded anymore?
That's probably another. It's probably in between embedded and servers that are running in cars. Yeah, absolutely. So yeah, also in recent years, I think you have works on probabilistic methods that evaluate impact of faults on systems in general. Can you elaborate on this, and are there any works that you have on using those probabilistic methods towards ensuring trustworthy AI?
So this was a very I'd say an important part of my research career, where I worked with other teams in Europe to a topic that at that time was called cross-layer reliability. And what we're trying to face is that if you want to assess reliability, you need to simulate everything you have in your system, the hardware, the software. And if you want to simulate everything at the same time, this takes too much time. So this probabilistic idea was like, if we take the different layers in isolation, this is much simpler, because you can think about evaluating your hardware without running complex software. And you get inside of what happens if you run particular small sequences of instructions and you have faults in some of the hardware structure. And you get a kind of probabilistic estimation of how your hardware reacts to faults. And then you can do the same with maybe the operating system in isolation. So if something is bad in the hardware, how does it impact the operating system? And then you can do the same thing at the software layer, the application. Then the complex part is, can you put everything together so that you get a final number that is a very reliable estimation of what happens at the entire system where it fails? And what we tried to do, in particular, this was part of a European project. The name was Clerico. We exactly tried to do that. With different teams, somebody was very expert in hardware characterization, operating system characterization, software characterization, and then we tried to build a model that could put everything together. And this basically saves you time and allows you to scale with the complexity. And was very interesting when we started. It was like a pioneer idea. But during the years where we were working on this project, also some regulations started to talk about this. In particular, new upgrades to the ISO 26262. They started to say, okay, you cannot do simulation of the entire system anymore. So you need to start thinking about assessing safety of different parts, and then having statistics and probabilistic models to put things together. And this is what we tried to do. We started back in 2013, so a long time ago. And well, now I think there's a lot of regulations that are going in that direction.
Mm-hmm. Very interesting. Now that I know you're involved in many European projects, I'm not sure what is or is there European policy regarding computing in the cloud, knowing that there is almost no major cloud provider in that is European? Technically, there are US providers. Especially for AI becoming mainstream, is this a perspective from trustworthiness perspective? If I reframe my question, would I be happy for my data to be stored, probably processed, probably used for training model if it is not even around me and it might be somewhere that I don't even have jurisdiction on?
I think European Union is not happy about that. Definitely, we lack the computing infrastructure. We lack IC producers. We don't have European microprocessors, and we don't have cloud providers. So basically, we are really weak. If any of the big players decide to cut some of the services or some of the supplies, Europe will be in big trouble. And yeah, in terms of trustworthiness, that's also a big issue. We don't really, of course, all the cloud providers, they try to implement the best security, but still, AI, the security of AI is still an open issue in research. So we don't know exactly what high security standards in AI mean. And to be honest, the European Commission is putting a lot of money into building a cloud infrastructure. Different European cores in different domains, from hardware, pushing the European Processor Initiative and building a European processors based on RISC-V, but also porting all the different software stacks. We are still, in my opinion, we are still far away. We reacted too late, and after outsourcing for too many years, especially the semiconductor industry to Asia, it will take a lot of time. And I think differently from the US, where they are reacting pretty fast in moving back some key asset. Europe is really into bureaucracy, and things are moving quite slowly. But definitely, we need to get something based in Europe. And I think the pandemic period taught us that you cannot really depend on services that are coming from other countries, because if those countries are shut down because of a problem, then it's a big issue.
Absolutely. So there are people who argue that the best strategy is, instead of chasing this cloud-based approach, it would probably be better to push more for things like edge AI and pushing more capabilities of actually processing AI in the edge. This is better for sustainability and potentially also for security. What do you think of this?
Can I answer this question with another question? What's the definition of edge? That's a big question mark to me, because I don't think there's a real boundary today between cloud, edge, embedded. And I still really like, that's a very old concept that Intel introduced 15 years ago, 14 years ago, this computing continuum. So the edge AI is a buzzword. To me, what is cloud, what is edge, it depends, is a concept, maybe how far is from you the computation. But if you look at some of what they call today the edge factories, they are just small data centers that are close to your place. So I don't have a real definition of edge.
So let me put it this way. So if you have two applications, one like on your watch is capable of processing your health data on your watch from a circuit perspective and giving you the feedback still on your watch. And there is no necessarily your data do not go anywhere. While the same watch, instead of processing here, probably for a better performance, connecting to some server and getting you back maybe a more detailed response. And that is exactly for me, at least, what to put the boundary between what is actually embedded / edge compared to what is actually in the cloud.
In that case, I think personally, I'm in favor of local computing. Not just security is one reason, but computing locally doesn't really mean that you have better security. But of course, if you avoid transmitting data, you can avoid a lot of problems. The other thing I think is power efficiency. We forget that transporting data is probably one of the major sources of power consumption.
Absolutely.
So not just performance, we managed to build a very powerful network, but we are moving so much data for nothing. So if we can bring more computation locally, I think first of all the benefit will be in less power consumption. In terms of security, maybe in terms of privacy, that would be better. In terms of security, I think there is not a big difference. Our local devices and the network connection, the remote servers are secure today, in my opinion. But the privacy is a different thing. The privacy is how people use your data. And that's a completely different.
That's actually interesting. Yeah, people generally confuse security and privacy. Privacy is centered about your right as regards to how your data is used and to what you actually consent to, while security is what we based on the confidentiality, integrity, availability. Absolutely. That is, yeah, definitely. And I think attacks, I obviously from a security perspective do not agree that whatever is edge or cloud is secure. I would say it is the same and both are insecure, but that's a matter of,
Yes.
And I think there is no system that is secure or insecure. It's a matter how you define what is secure. Yeah, so continuing on this security part, so with rising sophisticated attacks, probably some of them are in using AI. Do you think that on the opposite, we can leverage AI to enhance the security and resiliency of systems, especially from a hardware perspective? And if we do so, can we trust the defenses based on AI that we would potentially use?
That's a very interesting question. There are two different perspectives. So from one side, yes, I guess AI is a powerful instrument to help detecting different types of attacks. And if you think about security, sometimes it's very difficult for an algorithm to detect an attack. There's an attack ongoing, but a human being sometimes can guess that there's something wrong. And the latest AI models are really powerful, and they can start guessing things. So definitely they are a very powerful instrument. What I see on the other side is that the way we build security so far is that differently from safety, where we accept that a system is safe with a certain probability, and we accept that, okay, 0.01 probability of a crash, it's okay, because we cannot have 100%. In security, for many years, we have been building security with the idea of you can prove security. You have an algorithm that is secure by construction, and I can prove mathematically that you can break it. If you start using AI to detect security threats, you cannot have this security anymore. You need to enter in a security world where your system is security with a certain probability. And that means there will be always a probability of an attack to succeed. And I think this opens a completely different world. I think more on the legal issues than the technical ones, because we already know that there's nothing secure by construction. But legally, that's a completely different domain, and we need to change our mind. But I don't think there is any other way to go.
Absolutely. So just moving the focus to some of your works on approximate computing as a computing paradigm, do you see any intersection between this and trustworthiness, robustness, security of AI, either positive or negative?
That's a difficult question. I've been working on approximate computing for some years now, and sometimes I'm happy and excited. Sometimes I'm not fully convinced that approximate computing is really working. I think the application into AI is probably the best application of approximate computing, the most convincing application of approximate computing, because the idea of approximate computing perfectly matches the way we implement AI models today. But when I say it's convincing to me, it's because I think it's one of the applications where you can really gain in less power consumption. I'm not sure this will lead to increase in trustworthiness, and actually what you usually trade off in approximate computing is the accuracy of your model for something else, power or performance. So in my opinion, approximate is the only thing we know is that we are gonna lower the confidence we have in the model. This is probably exactly the opposite of trustworthiness and trustworthiness AI, because we want to trust our model. But again, power is important. So sometimes we can trade our trust to consume less power.
Yeah, and probably also sustainability is an objective that can be a part of trustworthiness. Why would you trust the system that's actually consuming a paramount amount?
Yeah, if you enlarge the definition of trustworthiness, then
probably this is from an ethical perspective more than anything, because I think I've read some numbers like training end-to-end, like those transformer-based language models. It has the higher carbon footprint than 300 flights between New York and San Francisco, and that's crazy. What are, in your opinion, the main challenges in maintaining the trustworthiness of AI, especially those are going mainstream, literally? And I think you have some works with application domains like medical domains and so on. What are in your opinion, the main challenges to trustworthiness of AI?
I want to start from the way I use these large models today. We all use ChatGPT to generate text, review text, and sometimes write code. And every time I use ChatGPT to create something, I need to check it. And many times there are serious issues. One of the problems I see in applications like medical applications is that at the moment I think the control between the data that you use to train the model and how you use the model, there is the distance is too large, right? So if I want to use for example these AI models for a medical diagnostic, I need to be sure that this model has been trained on data that I can trust, not on everything that you can find at Google, because out there we have no control. We have data that may claim exactly the opposite of what is real, and your model is poor guy. He doesn't know that this information that is available on the network is. So I think our models are very powerful on the algorithmic side. They are not trustable on the data we use. So maybe at some point we need to start training models for specific purposes on highly qualified and certified data. And then I would be very happy to trust a model. You still have uncertainty, your model is not fully precise, but also a doctor is not 100% precise. And your model will not be tired, will answer all the time. So data, trusting your data, the data used to train, in my opinion, is a big issue.
Yeah, that's interesting to have. One of the windows of trustworthiness is even look away from the model and ask, is your data itself on which you train your model is trustworthy in the first place? And that's very interesting. One more perspective, Stefano, and we had a little bit of chat about it last night, is if you consider this impact mainstream, not only, so you mentioned yourself how you use those models and the fact you have some critical thinking of the feedback you receive or the output you receive. Do you think there is some concern on the mainstream use? Is there any potential harm that you see that might lead to thinking again of getting this mainstream?
I do think this will create a lot of problems in the future because if you I think about an average user with zero technical education. It could be my mother. She's from a different generation, and somebody tells you that there is this wonderful technology that answers all your questions, and somebody advertises you that it's powerful, knows everything, has been trained on all data that exists in the world. And every time you ask a question, you get an answer. At a certain point, you believe that answer is correct, even if maybe it is not correct. And let's not forget, transformers were invented to generate content, not to generate correct content. So they only want to give you something that looks like generated by a human. They don't really care about what is generated. This will be a big problem as far as new generations of students start to study based on this. We already saw we moved from books to Google, and this was already a problem. Now we will be moving from Google to GPT 5, 6, 7, 8. And so the way a student will work is, okay, I need to study this topic. Let's ask to the generative AI. That's an issue. The answer is not correct, and you cannot trust the answer.
Yeah, so probably the most important skill, at least mainstream, which not it's easy to mention, but it's not easy to implement, is critical thinking. And probably one of the main skills that we want to teach our students is to think in a critical manner in general, and this applies also to AI as well. So let me ask you one final question, Stefano. What is the next big question you are working on, you or your team are working on, and what is the next area of research you're particularly excited about?
My next step, and we had a little chat during these days, is I'm really fascinated about the way our brain works. Our brain is powerful, is extremely low power, and the direction the AI domain took is far away from the way our brain works. On the other side, there is this, I call it small community that is working on neuromorphic computing that is definitely ages behind AI, what AI is today, but is closer to the way our brain work. And we are ages behind in models, we are ages behind in hardware, and we are ages behind in the understanding, the computation modeling of our brain, even if we know a lot about our brain. I have great expectation from this domain. It's not something we will see in 2-3 years on our cars. I think it's something for the next 10-15 years. But
Just for the context, the neuromorphic here, Stefano, you're talking about architecture like spiking neural networks, in which you kind of almost mimicking what a biological neural network works.
and
Why is this relevant? Why is this important? Why are you excited about this?
it's
technology?
because the whole origin of AI was to mimic the human brain, and we took a direction that is far away from the way the human brain works. And this the people working in neuromorphic, they started to model just a small part of how our neurons work. So these spiking neural networks, they cover just a specific electric phenomena that happens in a neuron. There are tens of different electrical and biochemicals things that happen in a neuron, and if we can understand them and model them, I think we may have a computing platform that is more powerful than all AI today, and will be super efficient in power. And who knows what we can reach.
Yeah, no, that's very interesting because some of my works are on the security and privacy, and we tested those neuromorphic systems, and I think they have very high potential of not only offering a byproduct, as you say, power efficiency, but hopefully even security and privacy towards, who knows, maybe the trustworthy AI would be neuromorphic.
And if I can comment, I think that if you want to move a step forward there, we need to involve people that know how the brain works, and they speak a completely different language. So it's even more difficult because it's not just engineers, computer scientists. You need to get people, biologists. You need to get people that studied neuroscience all together. You need to make them speak a common language,
Which is not easy. We talk across frontiers.
I have biologists in my group, and I can tell you that's super difficult. And well, if we manage that, I think this will be the next step.
Absolutely. And generally breakthroughs come sometimes from the frontier between disciplines. Well, thank you very much, Stefano. I really appreciate your time and your beautiful insights on this. And yeah, hope to see you soon. Thank you very much.
Thanks.